And I think you are having doubt in this concept of finding the relation between HCF and the LCM and the
Yes.
numbers, right? Okay.
Yes.
See, basically now, whenever two numbers are provided to you, let us take any two numbers. Let us take the example of
34 and 69.
34 and 69. Okay, good. 34 and 69. We have taken two numbers. Now, the product of these two numbers. Product means multiplication, right? When you multiply these numbers, so you would be getting some answer. Okay, now. So the value that you will be getting after multiplying these two numbers now, you will be getting the same value when you multiply their HCF with LCM. Huh? When you multiply 69 and 34, you'd be getting some answer, right? And that answer would be same answer when you multiply their HCF and LCM. That is the simple concept. And that is what the rule says. Is that not clear to you?
No.
Not getting it. Okay, let us first of all find the product of 69 and 34. Let us multiply these two numbers. So upon multiplication of 69 and 34, the value we should be getting should be around 2346. Okay. This is the value you will be getting. Okay, now let us find out what their LCF and HCF is. Normally, if the question asks you to find the product of HCF and LCM, by rule, I know I am going to get the same value. Rule से मुझे पता है कि product of HCF and LCM will be same. LCM और HCF की product same होगी जो product हमें in numbers के मिले हैं. Getting it, Happy? But still, let us check this. फिर भी हम इसे verify करते हैं. So first of all, find the HCF of these two numbers. Okay ना? LCM find करते हैं, HCF find करते हैं. Let us use the division method. Okay. 34 twos are yes.
34
Big.
twos are 68.
68. 69 minus 68, that is 1 over here, right? And then you take the number 34, right now? 134s are 34, right? Right now. So what answer am I getting over here? I would be getting the answer as 1. 1 is the HCF, right? You can use any other method also to verify this. Getting it? 1 is the HCF of 34 and 69. Okay. Now let us find the LCM. Using the short division method, let us try to find it out. So it will be 34 and 69. Okay, so let us start with 2. Okay, now 2 17s on 34, 69 is not divisible, so write it as it is. Okay, now let us start with 3. Okay, so 17 is not divisible, right? So just write it as it is, while 69 is divisible by 23 times. Okay, now we can't proceed any further because we have got the prime numbers now. ये दो prime numbers है, so we can't proceed any further. We stop over here. So the LCM will be simply the product of these two numbers now. 2 times 3 times 17 times 23, right? That is 6 times 17 times 23. Okay, 17 6 are how much? 17 6 are we know that it is
102.
Good. And multiply it with 23. So quickly do the calculation and see what answer you are getting.
What should we do?
Multiply 102 with 23. Quickly do this.
2040.
That is wrong. Not 2040. You should be getting 2346. Improve your multiplication. 2346 is the answer you should be getting. Okay. Let me see how you have done it. Can you show it in the camera?
Oh. I
Or
have
just
done 100 to 27.
no, it's clearly mentioned over here. You have to multiply with 23 now. Okay,
Yeah,
so
yeah.
that is
I'm doing that.
2346. Okay, so what was the HCM HCF we have calculated?
2346.
HCF
One, one, one.
HCF, that is one now. LCM is
2346.
okay. So their product is equal to basically
Same.
2346. So aren't we getting the same value? Huh? So here what we have done now, हमने HCF and LCM separately find किया. Then we multiplied them and then we are getting this 2346. Okay, now? So this basically proves this law now. The law which I told you in the class, which we studied, that product of any two number, first number and second number, any two number will be equal to the product of their HCF and LCM. So agar question mein, if the question is asking you the product of HCF and LCM, question is not asking you about what is the HCF or what is the LCM. Question simply आपसे पूछता है what is the product of HCF and LCM, and if the numbers are given, so can't you directly find the product by simply multiplying the two numbers? Like
Yes.
what I'm trying to say, you see we are provided with two numbers like 15 and 12 हमें provided है. ये दो numbers हैं. These are two numbers, and you need to find the product of their HCF and LCM. Huh? So will the product of HCF will not be same as 15 multiplied 12, that is 180. HCF LCM की भी product 180 होगी, right?
G.
Getting it now? So that is what the concept says. That is what we have learned. So that is the simple rule. Hope you are getting it. So the product of HCF and LCM of 8 and 28 is product of HCF and LCM. That is what we have learned. Product of HCF and LCM. We found out it by directly multiplying the given numbers, or in fact, हमने HCF and LCM भी find किया separately, and even then we got the same number 2346. So there is no need to do all this. Even if the two numbers are provided, you can directly find the product of HCF and LCM. Right now, that is one thing. Now, can you do the question number A, B, and other questions in this?
Okay.
Do question number A.
The product means after we get HCF and LCM, we have to multiply both.
Product simply means multiplication. Product
So-
simply means multiplication. Yeah.
So we just need to multiply 8 and 28
Exactly. As simple as that. Okay.
and nothing.
Nothing. Because the rule, as per the rule, we know that product of any two number, first number multiplied second number, is equal to the product of their LCM and HCF. Meaning that हमें दो numbers provided है, first number और second number. Okay ना? इन दो numbers के product, it will be same as the product of their LCM and HCF. Okay.
So the product will be same. Like LCM is same the answer, then HCF also.
No. See, basically over here, no. What are the numbers provided? Numbers provided हैं 8 and 28, right?
Yes.
See, when I say product of 8 and 28, product means 8 multiplied with 28. Product of
Yeah.
8 and 28 means 8 multiplied with 28. Okay. Product of LCM and HCF means LCM multiplied with HCF. What does product of LCM and HCF mean? Repeat what I just said. I said that product of LCM and HCF means LCM multiplied with HCF. Repeat this. Yes, Habib.
Yes.
The product of LCM and HCF means that LCM is multiplied with HCF. And as per the rule, we have learned that it will be same as the product of the given numbers. So that would be how much? Simply multiply it and find out the answer. Yes, Habib, by now you should be done.
Answer is 294.
224, not 94. Okay. Where have you done the mistake? 8 eights are 64. You carry on 6. 8 to the 16. 16 plus 6. That is 22 now. Okay. In the same manner, find out the product of HCF and LCM of 6 and 26. Do the second question quickly.
$156.
156. Very good. So hope you have understood this. Have you actually understood this or not? Please let me know. Yes.
Yes.
Have you actually understood the concept or just nodding yes?
Yes, I have understood.
That's good. Okay. That is one thing. Furthermore, another question says that HCF of two number is 1. Okay, now let me just erase all this. So HCF of two number is 1 and their LCM is equal to their product. Are the numbers co-prime? Are the numbers co-prime? So first of all, do tell me, what do you understand by co-prime numbers? We have learned about this in the class.
Co-primes
Hmm.
are like
Basically a pair of number. Go on if you can recall it.
I'm thinking.
Okay, think about it.
I don't know.
Okay, see, there are two numbers. Say you have the number 7 and 9. Okay. Their factors for 7, it is 1 and 7. For 9, it is 1, 3, and the number itself 9. Okay. Now these two numbers, the only common factor that they have is 1. The only common factor between them is 1. Right now? So co-prime
Sir,
numbers, yes.
that's like twin prime.
Yeah, co-prime or twin prime. See, both are
Both are
different
same.
things. Both are different actually. Twin primes are different from co-primes. Okay, no?
So this is co-prime.
This is co-prime. Okay, na? Co-primes are basically a pair of number that doesn't have any common factor other than one. The only common factor between them is one. Okay, getting it now? Well, talking about twin primes. So talking about twin primes, the two twin primes would be differing exactly by the number 2. Like say for example, 3 and 5, 5 and 7, 11 and 13. All of them are prime numbers, pairs of prime numbers, and their difference is 2. Like 5 minus 3, their difference is 2. 7 minus 5 is 2. 13 minus 11 is 2. So they are called as twin primes. Okay, na Habib?
Yes.
Okay, I think that you are not revising your notes. Okay, that's why you are forgetting the concepts. It's important that you actually revise the notes once in a day. Okay.
So what did
So
you say?
question says that the HCF of two numbers. I say that revise the notes.
Your voice was breaking.
Just 1 minute. Give me a moment. Let me change my network connection. Yeah. Now am I audible?
Yes.
Okay. I was saying that revise the notes. Okay, na? So that you don't forget the concepts, Habib. Okay.
So in my notes, there's not written co-primes.
Now, if you go back to the notes in the previous classes, we did learn about it. You might not have written it, Habib.
Yeah.
Okay, see. The question number C, the HCF of two number is provided as HCF of two number is 1. And the LCM is equal to their product, right? So the HCF of two number is 1 and the LCM is equal to their product. Are the numbers co-prime? Are you understanding this question or not? So first of all, try to understand the question. The question says that the HCF of two number is 1 and their LCM is equal to their product. Are the numbers co-prime? So it's a question that are the numbers co-prime. Okay. So let us first of all try to understand what is given in the question. First thing given is that HCF is 1, LCM is equal to their product, right? So it is equal to their product. Now we know that two numbers are co-prime if their HCF is 1. Remember, this is a property which we learned while we were discussing about HCF. We know that two numbers are co-prime if their HCF is 1 now. Let us take the example moments ago I gave you. I gave you the example of 7 and 9, right? What is the HCF of 7 and 9?
1 and 7, 1 and 3, and 9.
I'm asking you about the HCF now. What is the highest common factor?
1.
1 no? Right? So they are having HCF as 1. Getting it? So two co-prime numbers always have two numbers are co-prime. The number 7 and 9 they are co-prime if their HCF is 1. Right now? Getting it? That is another important thing to be noted down. Okay? Keep this in mind. Don't forget this thing. Also, the question says that the product of HCF and LCM of two number is equal to the, also we know that product of HCF and LCM of two number is equal to the product of the numbers, right now? Getting it now? Number
Yes.
1 multiplied with number 2. Let me just put it on charge. It just got discharged. That is something which we have done. Now, what are the steps which you are going to follow in this? The first step is that the question says that HCF of two number is 1. So thereby, the first thing that we know that the numbers are obviously co-prime. The HCF of two number is 1. So thereby, the numbers are co-prime. Okay, now? That's what the question is saying now. So here the question is solved. Hence, the numbers are co-prime. Getting it, Habib? Because in the question it is already mentioned that the HCF of two number is 1. Okay. So thereby, there's no need to do any mathematical calculation. The question itself is clear. Are you getting this?
Yes.
What did you understand from this? Please do let me know.
That the HCF is 1,
Hmm.
and if I mean 7 and 9 are co-primes, their HCF is 1, and
Not just 7 and 9. If HCF, if
other numbers also like co-primes.
other numbers, okay, na? For other numbers also. So if the HCF of any two numbers are 1, so thereby those numbers are co-prime. Hence, it is already mentioned in the question. So yes, the numbers are co-prime. Now moving on to question number D. The question number D, what does it says? Read the question. It says that the
Sir,
LCM of two co-prime numbers is equal to their.
Sir,
Here,
if
repeat.
the HCF is 1, then the numbers are co-prime.
Yeah, if the HCF is 1, then the numbers are co-prime.
Okay.
Okay, right? If you possible, if you haven't written that statement, please write that statement. That if the HCF of two numbers are 1, then numbers are co-prime. Okay, that's an important statement there. If you, I think you should write this down if you haven't written it earlier.
Okay.
Although if you go back to the HCF section which we have discussed, there this property would be written.
So should I write this?
Here, write down this. Done.
Yes.
Now question number D, it says that the LCM of two co-prime numbers, the LCM of two co-prime numbers is equal to their what? Okay. So try to understand this via one example. Okay. Can you provide one example of co-prime numbers? Yes, Habib. Give one example.
13 and 17.
13 and 17.
Yes.
Very good. Very good. 13 and 17. Question is saying the LCM of two co-prime is equal to there. Okay. So let us try to find the LCM. When we try to find the LCM now, we will observe that already both of them are prime numbers. The 13 and 17, these are co-prime numbers, right? So 1 13 so 13, 1 17 so 17. So thereby LCM will be 1 multiplied 13 multiplied 17. Or basically 1 doesn't have any significance over here. It isn't going to change anything over here. It is not going to change your final answer. So basically the LCM of two co-prime numbers will be equal to their product now. 13 multiplied 17, isn't it? So can't we just say that the LCM of two co-prime numbers is equal to their product? Right? The LCM of two co-prime number is simply, their LCM is simply 13 multiplied 17 as we find it out. We can take some other examples. Remember we had the example of 7 and 9. Okay now. So let us find their LCM. You do this thing. You did do this one. Find the LCM of 7 and 9. Using the short division method, find out its LCM. And take the number 3. Initially, take the number 3. Okay.
$63.
63 right now. So isn't the LCM simply product of the given number 7 multiplied 9? Right? Getting it? So whenever two co-prime numbers are given, we can find out their LCM simply by multiplying those two numbers. No need to do all those lengthy methods unless asked to do. Okay, Habib?
Sir, can I drink water and come?
Okay, be back quickly.
Okay. So I'm back.
Yeah. Okay, now moving on to the next question. So far you are getting it now? Now moving on to question number E. It says that the product of two numbers is 112. The numbers are not provided. Note down that the numbers are not provided. Okay, now product of numbers is provided as 112, right? Next thing provided in the question is HCF is 2. You have to find the LCM. Okay. Now number 1 multiplied number 2, we know that is equal to HCF multiplied LCM, right? A number 1 multiplied number 2 is basically the product of the number. It is called as product of number, right, Habib? The product of the number in the question provided is 112. Okay. The HCF provided in the question is 2. You have to find what is LCM. Okay, now? Getting it so far?
Yes.
Okay. We know that previously while we were learning about this, we know that if 3 of the quantities are given over here, right now. So the fourth quantity can be found in such a manner. Say in this question, product is given. Product of number is given and HCF is given. You have to find this quantity, that is LCM. So it is like this. HCF multiplied LCM equals to first number multiplied second number. For a moment, let us just call this as the product of numbers. Okay. Product of number that is provided. And what else is provided? HCF, that is 2. You have to find LCM. So LCM will be equal to product of number. Over here, HCF was in multiplication with LCM. Okay. Now, when you bring it to the other side of the equal to sign, its operation changes. Earlier, it was in multiplication. As you bring it to the other side, it will come in division. So it will be product of number upon, sorry, it should be HCF, I mean to say. It would be upon HCF. Getting it so far?
Yes.
This what we have done. Have you understood this completely or not? Please let me know.
Yes, I have understood completely.
Good. So thereby, we had to find LCM. What was the product of number given in the question? That is, yes, Abhi, pay attention here. What is the product of number provided?
112.
112. And HCF is This is 2.
Yeah,
So
2.
112 upon 2. Quickly divide this. As soon as possible, divide this quickly.
$56.
That is 56. Very good. You just hold on for a minute. There's a call, important call coming. Got this, no? That is how it has to be done. Now, moving on to question number 2. Okay. Here, the product of two numbers is given as 756. Okay. And HCF is provided as 6. We have to find the LCM, right? It's the same question which we did a moment ago now. Different numbers, but same question, right? Okay, Habib. So do this question yourself. Okay. Do this. I will be back in a minute. There's someone on the door. I will be back in a minute. Okay. So I'm back. Yes, Habib. Done.
No, almost.
Okay.
So this question, right? What is the least number of rows required to make
No. Question number 2. I gave you question number 2.
the product of two numbers?
Yeah, the product of two number is 756.
So I got the LCM.
What answer you're getting?
126.
Very good. Okay, now so that is the right answer, in fact. Okay, that's good. Now in question number 3, the HCF of two number is provided in question number 3. The HCF of two number is mentioned as 15, and their LCM is mentioned as 315, and one of the number is mentioned. Let us say that number 1 is given as 45. You have to find number 2. You have to find the other number. Okay, now so isn't that very simple? As we know, HCF multiplied LCM is equal to,
Sir,
yes.
I want to ask you something.
Hmm.
Was my method correct? I did like this. 756 divided by 6.
Yeah, that is correct. Okay, na? But make sure
Okay.
that before we jump on to the calculation, you write all this also. Okay, na? First of all, in the question, you will write down whatever is mentioned. Okay, na? Write down HCF is given this, LCF is given this, whatever is mentioned in the question, first of all, write down. Okay. And after this, over here, 15 multiplied 315, like in this question. Number one is provided as 45. Number one is not provided. Number two is not provided. Okay, now second number is not provided. So this will be number two will be. Now you have to change the side of this. Okay, now. So number two will be 15 multiplied 315. Now change the side of 45 from here to here. Here it was in multiplication. Bring it to this side. It will go to division. Okay, now that is number two. Now you have to calculate it. So first you will multiply 15 with 35. Okay, Habib. First we are going to
Whatever answer
multiply.
we get, we have to divide it by 45.
Yeah, whatever answer you get, then divided with 45. Okay. That's how it has to be done. Okay, do one thing. You can do it after the class. Okay, now if you have understood the method, you will be doing it after the class. Okay, Habib. Since we are. Yes, Habib.
Yes.
You do it after the class. You have understood how it has to be done. You have understood the concept now.
Yes.
Good then. Move on to question number 4. Okay, question number 4 says that what is the least number of
Yes, sir.
roses? Yes.
After the class, I should do this, right? So whatever answer I get, should I send photo?
Yeah, you can send the pictures of the answer. Okay, now you can send the photo. I will verify that. Okay,
Okay.
I will go through it. Since I'm aiming to at least complete this exercise today, so that we can begin with a new chapter. Also, once the chapters would be finished, I will be asking the definition of different concepts and the definitions of different things which we have learned, like what are the different properties of LCM and HCF, what are composite numbers, what are prime numbers. So in the next class, make sure that you revise all the concepts before the next class, okay? Because for the first 15 minutes, I will be asking the different concepts. Once I will be assured that you have memorized every concept, then the next chapter will be started, okay? Now, next question says that the next question says that what is the least number of roses required to make equal number of bouquets of 15, 20, and 25 flowers, right? Okay. So here basically what we need to do, question number 4, equal number of bouquets of 15, 20, and 25 flowers have to meet. You understand what is a bouquet, right? Okay. So the equal number of bouquets should be basically their least common multiple, basically the LCM of the given numbers over here. Getting it? The least number of flowers required to make the equal number of bouquets should be basically their LCM. Getting it so far? So in this manner, it has to be calculated. Okay. Hope you are getting it. So then simply find the LCM, you will be getting your answer. Then moving on to question number 5. Question number 5 says that a church has 3 bells. A church has 3 bells. Further, it mentions that one rings every 3 minutes. It rings every 3 minutes. The another every 4 minutes. right? And the third every 5 minutes, right? If they all ring together at AM, at AM, 8 AM, they all ring together at AM. At what time will they ring together again? Yes, Habib, you're getting this question?
Yes.
The question is that a church has 3 bells. One rings after every 3 minutes, the other after every 4 minutes, and the other after every 5 minutes. Right now, if they all ring together at AM, so at what time? So at what time will they ring together once again? Understood the question? Hope that thing is clear. Okay. So let us try to understand how it has to be done. Now, in order to find when all 3 will ring together, we have to find LCM of 3, 4, and 5. You have to find the LCM of 3, 4. Yes.
480.
Repeat again.
480.
I don't think it should be 480. LCM of 3, 4, and 5. Calculate it. Take the number 2. So the LCM will be 2 multiplied 3 multiplied 2 multiplied 5. It should be 60 now. The LCM will be 60. Getting it?
Yeah.
So the LCM of these numbers are 60. Getting it? Further, the question was saying that they all of them together ring at 8 a.m. They all of them ring together at 8 a.m. So then, what will be the next time when they will be ringing together? That part of the question is clear to you or not? Three, 4, and 5. That is 60 minutes. So you'll be taking this as 60 minutes, by the way. The interval is 3 minutes, 4 minutes, and 5 minutes. The LCM of the number 3, 4, and 5, we have found it to be 60 minutes. So therefore, these 3 bells will ring together every 60 minutes. So earlier it rang together at 8 a.m. So after 60 minutes, basically we are talking about 9 a.m. now. So after exactly 1 hour, they will be ringing together. Are you getting it what we have done over here? I think you are not getting it.
Yes.
See what the question says, that there are 3 bells in a church. Yes, Abhi?
What?
What were you saying moments ago? Repeat again.
No, nothing.
So there are 3 bells in a church. One of them rings every 3 minutes, another one every 4 minutes, another one every 5 minutes. So let's say the further question is mentioning that if they all ring together at 8 a.m., whenever the handle of the clock strikes 8 a.m., all of them would be ringing together at the same time. Okay, now? So further question says that at what time will they ring together again? So in order to do that, first of all, we found out their least common multiple. That is 60. Okay. So we are taking this as 60 minutes. Okay, now? Because it is 3 minutes, 4 minutes, 5 minutes now. So that is LCM is 60 minutes. The unit is mentioned, that is they are in minute. So after 60 minutes, that is at 9 a.m. they will be ringing together again. Have you understood this or not?
Yes.
Understood this? So hope that is clear.
Yeah.
I hope you have understood this. Okay, if you have understood this, I'm giving one question of the same nature to you. Okay, now? If you have understood this, so solve this question of the same nature. Say that 3 bells starts ringing at, or say that there are 3 bells in a church. Okay. The first one rings at every 10 minutes. Another one rings at every 15 minutes, and third one rings at every 20 minutes. Okay, so do tell me that, say that if all the bells rings together at 12 o'clock, so at what time will they ring next? Okay, na? At what time will they ring together next? Same question but different value. Okay, you got what the question is saying now?
Yes. Do you have to do it?
Yeah, you have to do this. 3 bells provided, and the first bell rings at every 10 minutes.
They'll ring at 1 o'clock.
At 1 o'clock. How did you find it out?
By doing the LCM.
What LCM you got?
60.
60. That is 60 minutes basically, right? So 12 o'clock after 60 minutes, that is at 1 o'clock. Very good. Okay, I hope you have understood this. Okay, now moving on to next question. So the next question is question number 6. I'm erasing all this. Okay. Find the greatest number that divides 47, 77, and 89, leaving the remainder 5 in each case. Okay, now. So the question is that the numbers provided are 47, 77, and 89. So we know that the highest common factor of these numbers would be, if there's a highest common factor of these numbers, it will be divide them and leave the remainder 0. Right? That's what we know. Right now? ये concept हम पढ़ते हैं HCF में. It will be the highest number that will divide them, leaving the remainder 0. But in this case, you have to find the greatest number that will divide all of these numbers, but it will leave the remainder 5 in each case. So think of this for a moment. I want you to think about this. Have you tried solving these questions yourself?
No.
No? Okay. Think about this. That in the given
I
question,
guess we should find LCM by doing.
No, you don't have, it doesn't have anything to do with the LCM. Okay, na? It doesn't have got anything to do with LCM. Okay. Think of this for a moment. Although I'll be helping you in this, but I want you to think about this for a moment.
I'm doing the working. Can I do?
Okay. Yes, Habib. Let me help you out with this then. Okay. So the question says that the greatest number that divides 47, 77, and 89, leaving the remainder of 5 in each case. So what that number is? Remainder of 5 should be left. Okay. So first, okay, you're doing okay.
I didn't understand.
Okay, guys. Sure. See, the numbers provided are 47, 77, and 89. Now, as we know that the greatest number which divides two or more number is known there HCF. But here we have to find the greatest number which divides 47 and 77 and 89, but should be leaving remainder as 5. It should leave the remainder as 5. So what should we do now? Let us subtract 5 from all these numbers. 5 hum subtract karte hain. It would be 42. It is 72 and it is 84 now. Okay na? Now find out their HCF. अब हम HCF find करते हैं 42, 72 and 84 के. Okay, Habib. Let us find it out by listing method. 1, 2, 3, 6, 7, 21. Oh, by the way, 14 also. 14 is a factor. 21 and then the number 42. These are the factors of 42, right? Okay, come on. Tell me the factors of 72. That is 1 and then 2.
2, then 3,
Then
4,
4.
then
Yes.
8.
8. Okay. Then 9. What about 12?
Yeah, 12.
Okay, no? Okay. What about you missed a number 6 now? 6 is also no a factor. Okay. You have 12, you have 18, you have then the number 36 is there, and then you have number 72. These are the factors. 84, 484, it is 1, 2, 4, then 6, right? Then 7, right now. After 7, you have 12. After 12, we have, yes, which number?
36.
36. No, 18, not 36. 18. Not 18, neither 18. Think of this.
84.
21. 21 4s are 84. After this, you have 42 and then 84. Now, the only common factor which I am getting now, the only common factor for these numbers, you can clearly spot it to be, yes, that is 6 now. 6, 6, and 6. Getting it? That is 6. The HCF is 6. So thereby the numbers should be divided with 6 in order to get the HCF as 5. You can check this out also. Like 47 when divided up with 6, 6 40, divide this with 6 sevens are 42. Remainder is 5. Or 77 again divided with 6. 6 ones are 6. 6 twos